Question 12. The value, V pounds, of a vintage car T years after it was first valued on the 1st of January 2001 is modelled by the equation V equals A P to the power of T, where A and P are constants. Given that the value of the car was £32,000 on the 1st of January 2005 and £50,000 on the 1st of January 2012, A, find P to 4 decimal places, and II and part A show that A is approximately 24,800. We then have to interpret the constants, what they mean, and then we have to find out when it exceeds £100,000, which year for the first time. So in part A, it says that the value of the car was 32,000 on the 1st of January 2005. So if we started in 2001, this is 4 years, so T is 4 here. And then it's 50,000, 2012, so I'd say that T is 11 there. So let's make some equations and we can solve them simultaneously. So if we put V as 32,000 in, so we're going to get 32,000 would be equal to A P to the power of 4. That would be one equation. And then if we sub in 50,000, and that would be equal to A P to the power of 11. And that would be our second equation. Now we can solve these fairly easily by using division. So if I do 2 divided by 1, that will cancel out the A's and it will leave us just with P. So what would that look like? So 50,000 divided by 32,000. That would be equal to A P to the power of 11 divided by A P to the power of 4. And that's nice because the A's would cancel, and then P to the power of 11 divided by P to the power of 4, which is P to the power of 7. So this means that P to the power of 7 is this thing. So then that means then that P will be equal to the 7th root of 50,000 divided by 32,000, which is 1.5625. And so that means that P, and it wants it to 4 decimal places, will be 1.0658. We then need to show that A is approximately 24,800. So if we go back to equation 1, we now know what P is. So that means that 32,000 will be equal to A multiplied by P to the power of 4. So that's 1.0658 to the power of 4. So that means that A is going to be equal to 32,000 divided by 1.0658 to the power of 4. So that gives us A, so a bit more accuracy than we need, 24,796.8, which is approximately equal to 24,800. So we've shown what they wanted in part A. Part B, with reference to the model, interpret the value of the constant A. So we look to our model, V equals A P to the power of T. So if T was equal to 0, P to the power of 0 would just be 1, so V would just be A. So effectively A is the value of the car at T is 0. So for part I, it's the initial value of the car. Or you could say value of the car on 1st of January 2001. So part B, II, we need to interpret the value of the constant P. So P is effectively your multiplier. Each time T goes up by 1, we're multiplying by P. So what we can say is it's the factor by which P rises each year. If you remember from compound interest, GCSE, so our value of P was 1.0658. So you could see that this 0.658 is your percentage increase. So you can also say increases by 6.58% per year. This is your percentage multiplier. So that's our interpretation of the values A and P in our equation. So for part C, using the model, find the year during which the value of the car first exceeds £100,000. The equation we created was V equals 24,800 multiplied by 1.0658 to the power of t. And we want to know when this exceeds 100,000. So if we equate it to 100,000, so we're going to get 24,800 1.0658 to the power of t equals 100,000. So let's rearrange that. So 1.0658 to the power of t will be 100,000 divided by 24,800. And so we're going to have to use logarithms. So t will be equal to log, and our base is 1.0658, of this. And that's going to give us t is equal to 21.8. So because we began on the 1st of January 2001 and we want the year in which it would exceed, so it would actually happen in this 21st year. It would be towards the end of the 21st year. So after 2001, that implies the year will be 2022. For all of 2023, it will be above 100,000, but partway through year 2022, it will exceed 100,000. So that's our answer to part C.